first thing, if you haven't been seeing the website carefully, you will notice that I have uh, converted this document cleaned it out and put it there. AI in the cloud with Java. It's the same notes, but some of the clarifications that you were asking for during the class are here now. So just to recap, we have gathered here uh, to look into considerations of deploying an application to the cloud. In particular, we took the Kubernetes engine of Google, which is extremely resilient, actually, very, very scalable and resilient. Google brags that it gives you can create planet scale clusters and so forth, and application scale outs and so forth. And I do believe that they are justified in their bragging rights because internally that is what they use for everything. Uh, so it's quite nice to see this open sourced, such a robust framework. And through experience in my teams that work with me, yeah, almost all of them who use Kubernetes, I mean, all of them, the ones who do use Kubernetes, they all swear by it. So it's a worthwhile technology to get into. It is something you can deploy locally on your own data center, in your own servers. And in cloud, of course, it comes as a service, much easier deployment. You just click a few buttons and you have a Kubernetes cluster. Of course, the price that you pay is that the cost of running it in the cloud is quite high. Right? For example, a modest cluster, as you saw, last time when we configured it, easily came to $400-500 a month. And that was a puny little cluster with hardly 16 gigs of RAM and 4 cores and some 30 GB of ordinary storage and so forth, creating 3 instances of that. So that is always been the trade-off in the cloud. I always see it as essentially 10x more expensive or 20x more expensive in terms of sheer hardware cost. But where people believe that it pays for itself is one is the standardization. Now, the other is with you don't have to maintain an IT staff. When you maintain an IT staff that can try to do all of these scripts, first of all, they might produce substandard results. Whereas here is one company whose entire mission is to give you good IT services. Cloud is nothing but their data centers and their IT people providing you services. So they give you more robust services. The other aspect is within the US and like I suppose if you look at the money aspect of it, as I have to, if you look at an engineer, even the engineers who do your deployment and IT, by the time you take their salary, the bonus, the health insurance, and all the incidental costs and everything, the outer financial envelope always comes to 250K plus, which means, and you never would trust having a team of less than 4. You need a quad. You need a proper pod of people to maintain any kind of services that you deploy to production and so forth. So by the time you have a reasonable staff of, let's say, 10 people, you're looking at $2.5 million in in basic overheads, in sort of a salary overheads. And I suppose what you end up saving is you say that, all right, for 2.5 million, I will get something which I don't know how good these people may be, but I could instead keep just one or two DevOps, one or two IT operations guys to manage the cloud operations and let the cloud people do the rest of it. So cloud gives you that simplicity. Once you factor that in, the cloud providers would have you believe that it evens out or is just as expensive. Though I think it depends upon, like if you are not into core technology group, you're better off with the cloud because you will have hard time building that core competency in-house. On the other hand, if you are a tech shop, of course, it's far less expensive to have an in-house data center which you use for most things. As an experience in my team, we have or I have instituted a rule that a large part of the development we do on the in-house data center testing, etc., because it's a bit expensive doing it in the cloud, and then we go to production in the cloud by and large. Right? deploy it to the cloud by and large. But some people don't do this. Some teams, they will only develop in the cloud itself, but stay within the budget. Some people, even now, just go to production in the data center itself, though we are moving them away to the cloud. So it's a mixed bag at this moment. And as you probably know, it is not a jury's out on which is the better option. There are many, many companies which have said, literally saved tens of millions or hundreds of millions sometimes, I think for some big use, famous cases, simply by getting out of the cloud and back into the data center because they realized that with sustained operation, it was too expensive to be in the cloud. So they did a hybrid solution. I believe Walmart also has a hybrid situation at this moment. Anybody from Walmart here? Oh, this batch is nobody from Walmart. Okay. So many houses are doing things like that. So that forms the backdrop of what we are doing. Now, what is the context of our lab? In this particular project, a lab, what we are doing is, we are going to definitely use the Google Cloud because we have been using it for the entire workshop, Jupyter notebooks and collabs and whatnot in the cloud. We are going to use the Kubernetes engine there. Now, what do? We need to create a Docker image and push it to the cloud. Now the Docker image of what? Our application, our microservice, our backend microservice. So the UI will interact with the backend microservice. Now, when you were doing your projects, you didn't need to. For example, if you do it with Streamlit, then your Python file itself is the application. And you take that to the cloud. Oh, by the way, I must apologize. I'm not sharing my video because there is no video on this Linux machine. Apologize for that. So anyway, you that is a single application as it is. But in real life, when you do a high scale application, enterprise grade application, the typical structure is that you have um, microservices exposed, which are scaled up, typically on Kubernetes, and your microservices are in Docker containers or container. There are other containers also, different containers, which are managed by Kubernetes. And you have these pods and scale outs and so on and so forth. You said elastic limits. When the load is low, the number of cluster nodes decreases. When it is high, it increases. You have vertical and horizontal scaling and so forth. And you have a ton of monitoring, ton of health check and dashboarding and so forth, because the worst thing that can happen is when you are getting millions of hits, you go down because customers remember that. Everybody remembers when Google has an outage, but they sort of assume it should be working all the time. The same applies to enterprise applications. So that's that. But the other question, so the front end, so you have microservices. Microservices these days, it is popular to write it in three frameworks. One is Node.js. Node.js is a JavaScript framework. It is it came about after, remember I was saying that Google created a very high performance um, JavaScript rendering engine, JavaScript compiling, and so forth. So using that and saying we can run it standalone on the server side, it becomes like an application container. And that is your Node.js. Starting with that idea, you build out the Node.js framework. Very popular amongst the JavaScript crowd. Its advantages are if you're very familiar with the front end, you can just write your backend with that. And many, many companies are adopting that. The second framework is you can write your backend microservices in Python itself. If you remember some of the early labs that you did, I encouraged you to write it in Flask or Fast AI. What is the advantage of that? Especially for data scientists, the advantage is that all data scientists are familiar these days with Python. So, and microservices are straightforward, just little routes or endpoints you put in your Python class, and you are up and running. So that is the Python way of doing your microservices. And then there is a third way, which is using a JVM. Uh, and one of the languages that the JVM supports, Kotlin, Scala, Java, Groovy, and so on and so forth. So there are trade-offs or advantages and disadvantages to each of them. The advantage of creating these things in Node.js is you can quickly, with today you have tons of people knowing JavaScript. It has a very slow, very low learning curve. You can do it. I suppose the downside that I see is that debugging Node.js is horrendous. Stack traces are not as elegant as what you find in Java, for example, where it is very easy to pinpoint the source of problems. In Node, it's a little harder. And by the way, voice your opinions, guys. If you're using these alternative frameworks in your workplace, you can voice a contrasting opinion because none of these are written in stone. I think there's a perspective at most that I can say I'm giving, not giving out the truth, but a perspective. So Node.js has that limitation, but barrier to entry is very low. Quickly, any JavaScript developer can be writing a microservice and getting the job done. The and then obviously you don't get the robustness of concurrency and multi-threading and all of those lovely things that you get in Java. Python, the advantages and disadvantages are Python gives you, especially for REST, etc., a fairly elegant syntax, clean syntax. Of course, the learning curve is you have to learn Python, which for data scientists is a no-brainer. Now you can take it to production. Flask is the default thing that most people use. But when you use Flask, actually performances are compared to enterprise grade things like a Java Enterprise server. The performances can be anywhere between 20 to 100 times slower, right? Because those things have been optimized over 25 years down to the metal now. So that's a trade-off with Python, but Python again has a low learning curve. For the data scientist, is very, very appealing. So for example, when you use Streamlit to just write your application, you will testify to the fact that it was far easier than even creating a Flask application and a React.js front end and so forth. Then, then comes Java, those houses that are very performance and scalability or reliability focused. Java has turned out to be in the back end nearly indestructible. I mean, I can attest to it from the fact that we have 100% uptime in 2020 for such a massive load system. So it's fairly indestructible. The ecosystem has been maturing now for 25 years. And there's a lot of open source libraries that people have contributed. So the big demerit is it turns out that the younger crowd and a lot of you guys don't know Java. It is a slightly harder language to pick up compared to Python, which has a one-day learning curve, or JavaScript, which has a one-day learning curve. But and let's say 1 week you become reasonably fluent with those languages. But with Python, with Java, it takes a while to know how to write good design pattern, code that is structured well, says Steve Leninger. But the positive side that you get is that you get absolutely battle tested libraries which have matured over the years. Apache Commons, Google Guava, and many, many libraries which are just absolutely battle tested. And application containers to run them, the engines to run this code, which are also seen about 20, 25 years of maturity. So the performance is blazing. And for server-side work, Java performance matches that or almost matches that of C or C++ performance, which is really admirable. In some places, it exceeds that. And now, of course, there's the additional fact that you can compile Java not to bytecode, but to just pure native code. When you compile it to a pure native code, it is like writing C code and compiling it to pure native. And the experience is, frankly, I find it very, very good, very fast. Now, what does fast mean? So why should we get excited about fast? See, when you're talking about cars, fast means more expensive, right? You go and get a car with more horsepower. It can go faster, have better acceleration, 0 to 60 in whatever number of minutes, seconds, 5, 6, 7, whatever seconds. So now you're paying through your nose because the car gets twice as expensive or thrice as expensive, or maybe almost sometimes 5 times as expensive. Right? On the other hand, if you in the computing world, the story is different. If you write your code and that code is going to run day after day after day, 24 by 7 for the next and typical lifetime of this code is, well, it varies, depends upon how well the code is written. I'm somewhat proud of the fact that I suppose we all have our bragging rights. My bragging rights is that the code that I wrote for NASA and CSA is still going strong. The code that I wrote for Oracle is still going strong, and so forth. So depends upon where you write. And there are 20 years, over 20 years now, but most code at least has a shelf life of about 4 to 5 years. Yeah. Um, so imagine a code that is running for 5 years on metal, on some sort of hardware, and the same code, and it's taking a certain amount of traffic load. And now in cloud, you're literally being metered by how much hardware you use. And now here comes another code which does exactly the same thing, but is 20 times faster or 100 times faster. The implications are immediate, right? So for example, if the same code needs $1 million worth of hardware, and let us say in the most fortuitous of all circumstances, you can write code that is 100x faster, right? You realize that you have gone from 1 million to $10,000. Right? $10,000 is the cost probably of you know, a large departmental lunch or an outing. $1 million is a budget line item that you have to justify. Yeah, the business has to justify. So, for example, what is the inflection point for profitability? At 10,000, you just need to have enough customers to break your. Let's say that you get $1 million, and let's say that there were a couple of developers involved, and so on and so forth, and you're doing a small business. Uh, if you're doing it in a language that's not very performant, if $1 million is just your cloud cost, plus there is a salary cost and setup cost and operational cost, you are still underwater. On the other hand, if you're paying $10,000, and then it is quite possible that with the high performance system, you have already gone beyond the inflection point into profitability. Right? So all of these considerations, they become real very, very quickly when you look at the financial aspect of it. Right? And I'm just speaking from experience because we sometimes acquire companies in which there's good IP, but very specific IP, but their deployment thing would be some, Node.js or Python and so on and so forth, and it would crash and it would be unstable and whatnot. And we would have to sit down and make it much more robust and scale it well. So you learn a lot of lessons for that, which is why in this particular lab, I took the unusual way of, instead of teaching you the simplest way to go to cloud production, teaching you a way that is actually going to help you in real life. Um, Gives you a path to write something that you can go to business with, yeah, and do well. I'm not saying that people don't go to business with Node.js and Python microservices. They do, and a lot of groups actually have rebased on that. But But there are also a lot of mission critical work done on these. For example, much of NASA even today it runs off Java ecosystem. So with that, there, the cloud, this document talks about the question that we have is quite interesting. See, we are as data scientists in this particular deep learning workshop, we standardized on PyTorch. We could have used TensorFlow or we could have done both, but already the course load was heavy enough. So we chose one and I preferred PyTorch. If you remember the prior versions of this workshop, I used to give in TensorFlow. PyTorch, in my view, is far more elegant at this moment, gives you more visibility in what's happening inside. Now the question is, once your model is built, how do you take it to production? For development, for training, Python is absolutely great. It is the language to use at this moment for deep learning. But when it comes to going to production, you need something that is rock solid. So can we, for example, deploy it in one of the Java containers, right, at scale? And so that brings us to this open source project and the context today. We will talk about how to deploy a Python model, whether it is TensorFlow or PyTorch or MXNet of Amazon or whatever, I mean, Azure's, Microsoft's thing, all of those, can you deploy it within a Java microservices and scale it out rapidly with Kubernetes and all that? That is the path that I've shown. And by the way, this sort of, if I may say, not many, you won't find this kind of a construction widely discussed on the web. To my knowledge, mm, at least I didn't find that widely discussed, but at least here we are. Yeah. I set up the instruction because I thought I'll write instructions based on what we do, yeah, which for us has been very successful. So now, when we do this, the question is, what are the pieces that I'm going to do? Okay, before that, let me just review what we did last time. So we did Kubernetes setup. Almost all of you got it right. Um, this is your cluster, you create a cluster, you're careful, you make 3 nodes, or you try to take older generation cheaper node or something like that. And then so on and so forth. I added a paragraph here for the Google shell. Like if you want to not do local setup, you want to just run it off the cloud, then just use these resources to pick it up from the cloud. Huh? And people do that, huh? Or people do that. And as far as I can say, they are successful with it. But the limitation of your instructor is I myself personally are heavily, right from the beginning, have been a heavy user of doing it from the Unix command line, local setup. So I'm showing you the way I do it and we do it in my team. And we have been, like, as I said, for us, it has worked out very successfully. See, getting to be proud of and say that we have 100% uptime in the world of reliability engineering is a big statement, right? Especially when you talk about a large enterprise deployment. So here we go. So I set it up locally. You all went through the steps. So I trust all of you have gone through the steps successfully. Let's do a pulse check. Are we all here?
Uh, so I was successful till the sanity check. When I came to 1.37 Docker support, I have an error.
And
It
what
says
is the error you get?
Docker not in system path. Docker and Docker credential G Cloud need to be in the same path in order to work properly.
Oh goodness, that's a
Yeah,
very Windows thing. Uh,
there seems to be permissions issues that were like default as editor and that we should be switched to storage access or
yes.
some
So
stuff like that.
let
And
me talk a
there
little
aren't
bit about that.
instructions on that.
Let me talk a little bit about that. Suppose you go to uh, let me go to this new table, um, Google Cloud Console. We are here. When you are here, and you pick your project. Where is my okay? Now, first of all, I need to become myself. My support vectors identity, guys. Wait a minute. I need to change my identity to support vector. ML400. Once you do that, go to this tab. You see this IAM and admin tab. Okay. Go here, and when you go here, you will see somewhere here. Let this load. You see these members, right? So what happens is that if you notice that your account, Google Service
Still
API,
quite
Compute Engine
small.
default
That's hard
service
to
account,
see. Could you
louder,
increase,
Kate, I can't hear you.
could you increase the size a little?
Yeah.
That's very small, even on my larger screen. That's better,
Okay.
thank you.
All right. So when you go here, what you can do, I think, let me remember which of these two. So what you do is you just go to these and just escalate their privileges, see what privileges they have. So in this case, this particular thing has a editor privilege, right? So if
Yeah.
you so wish, you can just go and add a storage. Let's say you can type a storage.
Bucket.
So go and app engine admin. Somewhere in here, there'll be a cloud asset, a compute storage admin.
Compute. Yeah, that's it. Compute storage admin.
Yes, exactly. So you have to
Right.
add a few of these, and I'm forgetting the exact one. So, or just give yourself a Kubernetes engine admin, right? We'll have access to everything, Kubernetes or engine cluster admin or something like that. By the time you give yourself these privileges, all of those little bugs, they tend to disappear. Now, what happens is in production zone, of course, your system administrator will be very strict about what privileges they'll actually give you, right? But for development purpose, it's fine. You can make yourself pretty, you can escalate your privileges quite easily, right? So, but remember that that's not what you would do in production. There you have to be super, super careful. And so you can do the same thing. Just go escalate your thing. The particular error you were saying, Kate, it is all permissions error. So go and
Yeah.
fix it here.
Yeah. In fact, it pointed me to uh, another link to deal with that.
Okay. And what did you do with that link?
Um, I'm on it right now.
Yeah.
It's container registry access, docs access control. It was right
Yeah.
in the.
That is right. You need to add those privileges. So this is in the IAM and admin. Go and boost up your privileges, and those problems will go away. Harini, you got that?
Sorry, sir.
Did you understand what I'm saying?
Yeah, I did that, sir. But I think mine is a different issue. It says Docker not in system path, though I set the environment
Oh,
Yeah.
you have a local.
variable and all that. Yeah, I have the Google SDK command from last time we, installed all that. But I can see the notes, but I'm not able to,
Okay,
uh,
what I'll do is I will have one of the uh, people who are participating in this workshop help you. Uh,
okay,
Name. I'll have him reach out to you to just sit with you and spend some time and figure out what is happening with it, with a
okay,
person with more Windows experience.
okay, sir. Thank you.
I'll have that person sit with you on a day. Let's do it right after this work,
Okay, sir.
so that your problems are gone. Huh? And
Okay.
Kate, let me know if you still have problems. I can couple you also to make sure your issues are also gone.
I'm trying to debug it right now.
Okay. So, all right, guys. So, assuming that you have all of those support, and if you find out that there's some instructions we need to add to this, some steps in this instruction list that I may have missed, let me know. See, with me, what happens is my environment is fully configured, right? And it's hard to know what steps were necessary fully, or I may have missed to mention in fully creating an environment from scratch. So let me know that.
As if there's one thing to add there. So I installed Maven from the Apache website,
Yeah,
but that doesn't bring the Maven wrapper, right? So in your command, you're actually saying MVNW. That's the Maven wrapper.
that is right. That will be created by the Quarkus program. That never comes from Maven itself. It is a script that just wraps around the Maven command to make it run locally, I mean, on your machine. So if you go into your Quarkus project directory, you'll see that. Let
Oh,
me,
okay. So it's not on the normal path. It'll be only in the Quarkus directory.
yeah, it is a Quarkus specific thing.
Got it. Okay. Yeah.
Right?
Let me look for it there. Yeah.
Yeah, so let me show what I mean. And again, let me increase the font size here. Suppose I go to ML 400. And if you go to the deep learning workshop and you go to, well, not here, maybe, no, this is not here. This is in GitHub. And let me, I'm forgetting all the, Where exactly did I create this code? Okay, I'll have to remember. Let me see that. Eclipse. Where did I create it? Eclipse, authored, workshop curtains. Let me see where I created the workspace for this project. ML400 cloud. Let's see where it is located. Okay, this is the location. GitHub ML400, ML400 cloud. So why do I not see that? CD 100. Yeah, here it is. I didn't see the obvious cloud. This is the project. So if you look at this project, do you see this MVNW? It is created by a Quarkus. It's very Quarkus specific. So for example, if you do MVNW, then you'll see that it maps to this. And again, I'll expand this. It is nothing but a shell script that wraps around Maven, and it takes care of the fact that people are on all sorts of, like for example, this is for Windows, this is for your Mac. You see that, right?
Okay.
That's
Yeah,
all
I kind
it
of
does.
thought it should have come with a Maven install. That's a mistake. Yeah. Let me look for it in the project file. Let's see. Yeah.
That is it. It doesn't do anything beyond. I mean, it's basically a sanity check, some extra sort of a helper thing to make it adapt to different environments. That's all. Yeah,
Thank you.
that is that. So, all right. So we are all together so far, isn't it, guys? So where we are is that we are going to then install JDK. Have we all installed the Java JDK, guys?
Yes, sir.
Okay, it's good. See, guys, I do realize taking you and just saying, okay, let's take this Python and wrap it up in a Flask and take it to production is a very, very easy set of instructions that hardly needs instructions, right? Deploying it to Kubernetes is very trivial. I'm deliberately giving you an instruction for something that is hard, but actually will benefit you when you take things to prod, in terms of cost, in terms of reliability, and so forth. So worth doing. All right, here we go. So you install Java, you install Eclipse. If you have not, now is a good time to become familiar with Eclipse, guys. There are tons of tutorial on Eclipse, and Java and Eclipse, they go together, right? The Eclipse Foundation is very, very influential in the Java community. They own the Java Enterprise Standard, pretty much the Jakarta EE, and there's a massive amount of synergy between these guys. So you create this project. We created a Quarkus project in which we included these things. So have we reached this far, guys? Have we all been able to reach this far? And when you do a local dev, are we able to see this application come up on our individual machines?
Yes, Asif.
We are all able to see that. Excellent, right? And you do that. And of course, if you do hello, then you will see the hello application / hello. You'll see the results. So now how do you deploy it to the cloud? So the first thing to know, if you're not familiar with YAML, these days, um, there is a new way people write configuration files. People used to write property files, and it used to get very messy, lots of properties and haphazard into place. So there are multiple ways of writing configuration. Java World properties files are very popular. Then other file format that's popular is the .ini format, INI format, which is again a standard. I believe there's a RFC or something behind it. And then there are some other formats in which you can have XML format, you can have JSON format. But very interestingly, this thing that seems to be where everybody has converged is YAML. If you ask people why, they'll say, oh yeah, YAML sucks. Yet, well, YAML is very convenient. Let's all use YAML. It's because it's so easy to read. It gives you a hierarchy, which I suppose XML would have given you or a JSON would have given you. But the syntax is so clean. You don't have a lot of tags and this and that. Try to imagine this in JSON and you'll realize what a mess it would be. So here, very much like Python, spaces matter, indentation matters, right? And it is key value. So when you say service type : load balancer, What it means is quarkus.kubernetes.service type is load balancer. Are we together? Right. That is important. Now, when you create your application YAML, when you say it is load balancer, what you are saying is that there will be multiple instances of this app. There has to be a load balancer routing the traffic to the different instances. Right. This is your registry. The standard registry is USGCRIO. You can play around with it and so forth. So we have stuck to the simplest possible things, tags. So you'll have to use your own project name, your own stuff, and do that. Now, once you do this, what happens is in your Quarkus application, you are saying that this is how I'll deploy to the cloud. When you deploy to the cloud, you try to deploy, what it happens is it will go and check your local um, system to make sure that your cloud keys are there. In other words, the secret keys and all of those things, they must have been taken care of here. Where are they? At this level, right? This command, you must have run it on your, and then you must, if you go to the .cube.config directory, you should see that, yes, your project has been properly set up. So by default, when you run the kube control get nodes, you should see your nodes running successfully, which means that it could get the authorization and it could do that. If that is done, then the rest of from that machine, deploying to cloud is very easy. By the way, this is something that, again, I don't know. If you're using Maven, but you're not using local Google SDK, but just using the Cloud Shell, I would imagine it would be a bit troublesome because you'll have to copy this code over, this project over to the Google Shell. That is a Linux instance in the cloud, and then do a ambient deploy. So, but I'm imagining, because I haven't done that before. So here we go. If you do this, then right away, you will see that your application is running. Right? Now, once your application comes up, and then some of you may have to do this, which you should do only in developer mode. It poses a security risk. But so there's a little bit of, imperfections here or there with the cloud. Everything is not perfect. So sometimes you can get away with it, but because we work on different environments, Mac, Windows, this, that, so there sometimes uh, you do hit glitches. And again, as I said, if you're doing these things from Ubuntu, you seem to have a very smooth sailing, actually. So a lot of these issues that you all are having, to me, comes as a surprise, because when I created these instructions, I thought I'd done a pretty good job. Every single thing I'd itemized, right? I had another person QA this, like actually take an Ubuntu and go through all the steps. And the person came back and reported to me that it was all successful to the dot. And then, but that's not your experience. There is some bit of struggle going on. So, okay, so how do you visit your application? So guys, have we reached, how many of you have been able to reach this part, been able to deploy to the cloud?
As if you go up, when you add that contain to the YAML file, one of the section, the container image,
Yes.
that's where I get an error that the container image is not allowed.
Oh, then again, go and fix your permissions here. Go boost permissions of these accounts, right? These accounts, these two, right? These two are the accounts that get created to deploy to your Kubernetes things, right? So these are
Yeah, it's
service
getting to
accounts.
be a
Just go and
problem.
boost their privileges.
So
So we
boost,
need to add specifically storage access and
Yeah, what I do is, yeah, go here and add some, like add roles or add this. So if you search for this, like storage,
yeah, specifically which ones, or we add every single one. I
no,
mean,
no, 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 no.
like to just add a
Compute
few.
storage admin, and no, there's a Kubernetes one. Actually, what I do, if I may just tell you, a cloud storage, hang on, ML services, GCS, cloud storage object resources. So what I do is, which I would suggest you do, because you're in dev mode These clusters are not bad. Just go and full management of and the Kubernetes API objects. Just go give yourself this print.
So Kubernetes, just Kubernetes engine admin will cover all of them, or do we have to?
Yeah, it will cover all of them.
Okay, because
And
I'm
try it out, see if that helps.
just experiment. Great.
Okay, so add that to the compute and
Yeah, that is it. Yeah,
this.
add it to those roles. And that should take care of it. If it doesn't, and anyway, I'll have somebody right after this thing reach out to you guys, those of you who are struggling, and fix your environment one by one.
Asif, where are we assuming all of us are? I'm at the end of 1.4, section 1.4. It's up, the app comes up. I mean, the web page comes up. Are we
Locally.
starting from 1.5?
Locally, yeah, locally.
Yeah.
I can't.
So we are, yeah,
Pushing the
so we are
image is an
talking
issue.
about 1.5 now, guys. Try it. Let's see how many of you succeed.
Do you do so once we add the permission, do we need to start or stop something?
No, you don't need to. So long as your Kubernetes cluster is running, make sure it's running. You cannot do this without a Kubernetes cluster running, and these things should match to that. You know, your group ID, your application IDs, etc. They should match the cluster, the entries there.
I also get messages about storage buckets. User does not have permission storage.buckets.get. And it keeps referring to me to that page about setting stuff up. And I've
Okay,
tried to
just
put some of the
add storage privilege also in this.
storage. Okay.
But you know, I'll give you the exact instructions, or I have somebody who is doing it on a day-to-day basis help you out. Okay. Um, if you just Google storage, then App Engine Cloud Asset, compute storage admin, full control of compute engine storage. Right. Try that. See if that
Which one? Compute.
compute storage admin.
Compute. Okay, looking for compute storage admin.
Yeah. Try it out. See what it does for you.
Asik, I'm getting error
Or you
when I
can just go and do storage admin, like, you know, full control of GCS. Yeah, go ahead, Rafiq.
yeah, I was saying I'm getting an error where it says starting the container image build and then base image, Fabric 8, Java, Alpine does not use a specific image digest. And then after that it says build failure.
Why don't you share your screen? Share your screen. Let's see what's going on.
Yeah, right now the roles I have is Kubernetes engine admin, owner, and storage admin.
Okay.
So you're saying I need to add something else too?
Oh, yes. So let me do it one by one. In your
Okay.
case, the base image requires, or try again, starting base image does not use a specific image digest, may not be reproducible. That's a warning that you can ignore. The,
Okay.
the base image, trying again, build.
Oh,
Okay, so let's look at this failure, build format, Java, unable to create container image. So this is a local problem, huh? Application. And did you include, go down, scroll down, message, caused by registry, okay. Credential problem, cannot run program Docker credential, yes. Permission denied.
oh, okay. Yeah, so another thing is that it was giving error, some other error. So I figured that Docker credential GCR was not installed on my machine. So I had to manually install it.
Yes,
And then I think since it is installed in /user/bin, it's actually sudo. So I think I will have to
cannot run.
change the permission to run as myself, not a sudoer.
Okay, guys, let me do one thing. Let's change the session to one-on-one help to each of you, and I'll pull a couple of guys in to help you guys individually so we can run through
Yeah, a
these.
lot of permission settings we need.
Yeah, let me do that. But let me just walk you through the whole flow, and then we'll convert it into a one-on-one help sessions for each of you
Okay.
to get you through this. But for the time being, let's pay attention to the flow. So the idea is that assuming that you have done make sure that you followed this step. Configure Docker. Did this succeed for you?
Yeah, I
So
did all
for me,
that.
it didn't succeed.
Yeah, for you it didn't succeed, Heidi, but for others, for Rafiq, did it
Okay.
succeed?
Yes, yes. I had already gone through these steps all the
Yeah,
way where it says deploy.
Okay,
yeah, the deploy step
okay, all right.
and the
So
build
then
breaks.
I guess you need specific help. There's something peculiar on your machines which we need to help fix.
Here in this 1.5, the group and the name, there are two properties there, right? So one is your project name, which is
Yeah,
group, yes, right?
yeah.
And then the name, so
Application name.
it's application name. Okay.
Yeah, or pod name. It also maps to your pod name and so forth.
As if for 1.5, do we expect this file to be already there, or we are creating this file from scratch?
No, if you go to, see, look at this. Now open SRC main resources.
Yeah, I don't find a file called application.yaml.
So if you don't have it, then create one.
Yeah, so that's what I was confirming. Yeah.
By the way, it should have gotten created. If you have not, you know what it means? It means that here you forgot to include YAML configuration. That's why. So guys, these steps now you have to meticulously follow. If you had included YAML configuration, then it must have been created in your.
Yeah, it is created as for me.
Yes, it is created. So you have skipped that, Premjit. Huh? That's all. So
Okay.
guys,
Yeah, I
remember
was
that
kind
these
of following to the dot, maybe by mistake. Yeah. Okay.
yeah.
Yeah,
So
the
guys,
eclipse
remember
can be
that
fussy.
if you don't follow these instructions,
Oh,
they have implications, and it could be that some of the errors we are seeing is because they're little, small because you're doing it for the first time. Little things you guys are missing. So read
Asif,
this instruction line by line and then do it.
yeah. Asif, I'm noticing in the Google Cloud Platform, the IAM, the permissions for my project, that there's not just, besides me at my email, I also have a project at developer.gserviceaccount.com and a cloud service. Um, so there seems to be two other
Yes,
kind
yes,
of.
those accounts are created. Those are your real. See, what happens is you never run. See, whenever you run an application, a process in a Linux,
Okay,
there is a user associated with it.
sure. Okay.
Now, basic security rule says that a real user should never be firing applications, not the root, not Kate, not this. What you do is you create specific. These are called service accounts. That's why the word service account.
Oh, okay. Then those still only have the role editor. Should I be adding?
Yes, I think you need to add. So hold on. Huh? I'll add
Okay, I think
help you
that's, yeah.
step by step. Huh? So that's that.
I see this block, quite a few syntax error it throws. Now that earlier error where you cannot add a container
Yeah.
image
So
is
the
gone.
syntax error you're getting is because of the spaces. You have to be very precise. If you don't get your, this is the downside of YAML and Python. It is space sensitive, indentation sensitive, very subtle mistakes in indentation, and it will show errors. So you have to reach a state in which your application YAML has no errors. Right? And once again, I think what is happening is there are small mistakes that seems to be happening because everything is very new. You guys need individualized help at this moment on a one-by-one basis. So let's convert this thing. Let me go through this entire thing and convert it into a after I'm through this whole into just a help session. All right. Are we together, guys, so far? So assume that this worked, this particular command in 1.5 worked. If that works, then what would happen is you can visit your Kubernetes engine and you will see it run. You see this IP address here, 34.105.40.63. It will be something different in your case. Just note it down. This is your public IP address for your microservice. And now anybody in the world can hit you on this IP address, right? Colon 8080. Are we together, guys? Is this visible on the screen for you guys?
Yep.
Yeah. So at this moment, obviously, it seems that not many of you have reached this far. What about you, Anil? Did you succeed with all these steps?
No, Asif, same step, like
Okay, yes.
same step as Harni.
Okay. All right. So let's us all solve that problem. And maybe there's something I did on my machine which I skipped in the doc. I forgot what it is. So the same, you can also get the same IP address by running this command, get service. So you'll get this command, this value. Yeah. So now you make a note of the external IP values. This is it. And then you can go and if you say this, you'll get hello world. And if you don't put hello, you'll get the same application page that you got locally. Right. So at this moment, what have we done? We have a Java application running within our Kubernetes cluster. Right? So we have put together two pieces of the puzzle, a Quarkus application, a microservice running in a Kubernetes cluster. So what you have achieved is something that will be really rock solid, assuming that your code is not completely screwed up. Yeah. Will scale well, will be rock solid, will perform well, and all those nice things will happen. But where is the AI? It is just a Java application that's running in the Google Cloud. We need to now plug in the AI, right? So that is step 3. Now there is this, let me take you to this library, Deep Learning for Java. I should have put a link here to the website. Let us go there. And, Java library. DJL.ai. So it is worth actually reading this. This is open source library to build and deploy deep learning in Java. Now, the good thing is that it's agnostic. You can do TensorFlow, PyTorch, whatever it is. And as you can see, the testimonials are from all the big guys, and they're all pretty upbeat about it. So it is not a trivial, somebody's GitHub project. It's a project with a lot of energy behind it. Right? So we are going to do that now. What do we do?
So Asif, this is similar to Onyx, right? ONNX.
No, Onyx is a data export format. Yeah. See, Onyx started out as a model export format, as a portable or an open standard for exporting models, Onyx models. And an Onyx runtime, yes, gives you the ability to run those models, assuming that it is exported in the Onyx format. What DJL does is that it supports Onyx, so it will use pluggable runtimes. It will, under the covers, use Onyx or MXNet or TensorFlow or Azure, or PyTorch.
Okay.
Based on your model, it will figure out which runtime it needs to do, and under the covers, it will automatically do it.
Okay.
And that is the power of it. Can you imagine that? You don't have to worry about it. It does it for you. Right? So this is it, beginners, and you can look into the examples, but that is the main point. And you should watch this 10-minute video. Spend some time, guys, becoming familiar with it, because I think this will give you a good way, because in your team, if somebody is doing some work with TensorFlow, somebody is doing with PyTorch, you're not creating 2-3 different servers to deploy their code. You have a common code path that will run all of them together. Right? You can literally load one model in TensorFlow, one model in PyTorch in the same Java app, and one model as a Onyx export. You could all run all of them together. That is its strength. So, Praveen, now you see the value of this, right?
Yes, sir.
Yeah, that is its main thing. It's very, very good. So you see this Apache MXNet, Onyx Runtime, PyTorch, TensorFlow, and you can go write your own extensions.
Okay.
Right? All of these. So imagine a single framework supporting all of this. So you don't have to do framework specific runtimes. Yeah. So for example, you spoke of Onyx. Let's go to Onyx and you see this. All you have to do is just add this in your Maven dependencies, this particular library. Right? And that is it. How do you load the code? Here it is. Iris model. Iris prepare. sklearn, cfit, preparing this, blah, blah, blah. Or create a translator. So you have to translate it into the Onyx format, of course. You do it, Satona, blah, 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 process input. Right? So you do all of these little things. At the end of it, you get a model and then you run the model. This code will look very similar to the code that we have done in a little while, but let's go back to our document. Okay? So deep learning for Java, in other words, gives you an agnostic platform for running different kinds of model within Java, within a fast runtime. Right? Now, it is an initiative. There are some other initiatives also, guys, and this is not the only one. So for example, I could have said, if you stick only with PyTorch, right? So there is the torch serve. They give you built-in sort of a REST endpoint for your models, inference serving models, right? So that is one initiative. TensorFlow, of course, has its own runtime and so on and so forth. So there are multiple efforts that you could use. This is one that we use because for us, it seems to work quite well. So once you have done these dependencies in your Maven project, then what do? Let's take an example code. And so this code, guys, by the way, in some sense, I would say, if you absolutely don't want to learn Java, then these instructions are not for you. Huh? You can just continue to use your Flask or Fast API within Python and survive with that. Or you can, for even simpler, just use Streamlit and survive with that, as you have seen. But if you do have familiarity with Java and you are familiar with enterprise grade deployments, large scale deployments, then this code will read very straightforward to you. Huh? This is the use of the builder pattern. Do you see that this is the builder criteria, and so forth. So very straightforward way of doing it. In this example, because for simplicity, this is a REST service, guys, the path/detect. Except that you don't give it an image. To keep it simple, they have hardwired the URL of an image in this code. So the way to understand this code is you go and open the image factory get instance from image. You create the image runtime object. And then what do? Your criteria is that image classifications. Do you see how it reads? My criteria for a builder is I'm building an image classifications thing criteria. If TensorFlow, which in your case is not, so you'll go straight to the else. Now, TensorFlow is a little more complicated. This is PyTorch is more straightforward. Criteria builder, set type, image, and classification is the task. Right. You can give it a ID, artifact ID. Artifact ID says which particular pre-built model or stored model to use. If you give it one of the standard names, like ResNet, what are you doing here? You're using transfer learning. Do you remember, guys? Transfer learning, right? And the first time you encounter ResNet, of course, it may not be on your local machine, so it will go download it. So this is a optional progress bar, and then you do a build. At this moment, you have basically what they call a criteria, but to the first approximation, you can say that is the description of the model you will use to do this task. And after that, all you have to do, if you look at this line of code, this is a specification of what you want to do. So one way to read it is to say, use ResNet to do image classification. That's all it says, image classification using ResNet. right? And if you're familiar with Java syntax, you'll actually consider the syntax to be a very elegant. It's called the builder pattern in Java.
As a quick question,
Mhm.
how do you get the ImageNet? It's not allowing to download for your general thing, right? So it needs organization.
You mean, no, I didn't get that ImageNet. This is ResNet, no? It's one of those pre-trained models,
Uh-huh.
not ImageNet, ResNet.
No, okay, now if you need a ImageNet data set, like you can download, right?
Oh, yes,
So
yes, download torch vision dot datasets.
okay.
No, it comes built in. Don't try to do it because there's some licensing issues. You'll have to apply for it and so forth.
Yes, yeah, that's what I was saying. I cannot go directly to ImageNet and download it. It needs organization name and
Yes, yes, yes. But why bother? Actually, in our Python code, no, in the labs, you'll see that we have used that torch vision dot datasets and so forth. Let's go to it.
okay.
Torch vision dot datasets.
So it's available through a Torch Vision dataset.
Yeah, yeah, it's already Torch Vision library is there. So what are the data sets you get freebie without thinking? All of these. Do you see? ImageNet is one of them.
Oh, okay.
Right? It's a pretty extensive list, pretty good range.
Yeah.
And for all learning purposes, these are great. Isn't it?
Okay. Yeah. Yeah.
Syllabus
Thanks.
for celebrities, CFAR, you know,
Mm.
right? CFAR 10, CFAR 100, and so forth. Those are subsets of ImageNet, so forth. So that's that. So we do that, and then, so what do you do here? So line 74 to 77 does what, guys? It gets you a predictor, isn't it? Now, when you go to the model zoo and load model, what are you doing? You're going to the zoo and picking up a pre-trained model, right? If the next example that I'll give you, once you guys are successful here, I will post it maybe next week, will be of how to, like, for example, the models that we have built. I will give you the Java code for loading that and running it. It's just 2, 3 lines different. That's all. It's pretty much the same code. Right? And so now you can use the model to predict, right? Predict and so forth, models. So the thing is that you don't do all this in reality in every get call. What you do is you do have your predictor saved, right? This entire thing you don't do. This is just an example code. In real life, you save it, and then at runtime, all you do is predictor dot predict given an image. That's all. So it will contain these 3 lines and the last line. That's all. And you return the results. That is it. And this is how the results get back to you. Right?
So Asif, where is the you convert Python model to here, right?
Oh, so when you export the Python model, the Python save model, it is just it is basically a hash map.
Yeah.
And they recognize the PyTorch format.
Okay. No, I mean it's there in this example what you are showing, or it's a different.
Oh, yes, yes. So for example, when you load ResNet, right?
Uh-huh.
The model ResNet, it is all, the model itself has been, is what? It is a bunch of weights.
Okay. Mm-hmm.
It will just load it and it knows it's ResNet. It knows the ResNet architecture. So it will immediately instantiate a neural network that is ResNet and apply those weights.
Okay. Mm-hmm.
That's it. So you don't have to worry about it. It will instantiate it under the cover. See, all you need are the weights, the model. After that, you can always recreate the same architecture in your code and apply those weights,
Now
pre-trained
for
weights.
our own model, how do you do that? Like
Same
in,
thing. So let me release the code for that. See,
okay.
I wanted to keep it simple because it's 2, 3 more lines. That's all.
Okay.
Yeah.
Mm-hmm.
I wanted to keep it as simple as possible because I can clearly see that a lot of people are quiet because they are not very comfortable with Java.
I think I've lost you on this description, Asif. Like, I'm not able to distinguish between what is sample code or what is like the template code and what is the specific additions to the template.
No, this is just directly a template code. It just shows you end-to-end flow. In reality, code is simpler than that. For example, this criteria and all of that, you don't do it all the time. At every request, you do it once. And then the only line that matters is predictor.predict. Think of your Python code. What do? You build a model, right? Classifier, CLF, right? Which is like a logistic regression dot fit or your neural networks dot fit to the data. After that, what do? You just call the predict method on your, if you're doing scikit-learn, you do clf.predict, isn't it? Do you remember your scikit-learn?
Yeah.
That's it. Yeah. So what do you do at the end of when your model is built? You just do predictor.predict. But before that, what do? You need to load the model. This is just loading the model, that's all.
Okay.
So guys, to get this, you have to refresh your Java. Otherwise, this will actually, if you know Java, this is very elegant, obvious, simple code. If you don't know Java, then it looks like, I don't know, it looks very cryptic. Yeah. And that is the one thing with Java, like to the people who are on the inside of the Java world, Java looks extremely simple and elegant. To the people standing outside, it looks like complicated mess. So you have to brush up on the Java. Anyway, so if you do this, it would be running. I give you guys a complicated set of instructions, but I wanted to give you guys a taste of the real world, thing, which will actually scale. If you can get this far and succeed with this, it gives you a blueprint for using it in your startup or in your workplace and getting a high performance runtime environment for inferences. Right? So you're doing inferences, given an image, you're telling it's a cat. For example, look at this prediction. It says it's a cat. Right? All of these first three things are all cats. Is anybody who followed this or understood what we did in this lab? Or was it too hard?
Yes, Ashla. So
To the extent
Able to
whether
follow.
permissions stop me from going further.
Yeah, but see, you may be struggling with the lab, but you understood the instructions, right? What it is doing, or the
Yeah.
general flow of it.
Yeah.
Yeah, good. That
So,
brings me to one piece of advice, guys. Pick up Java. You can't. Enterprise world is dominated by C, C++, Java. To expect people to pick up C, C++ is a tall order. Nah. People, it's a steep learning curve. Java is not so steep, but don't limit yourself to just JavaScript and Python, because soon you'll hit a wall at some point. Go ahead. Somebody had a question.
no, so we deployed it to a Kubernetes and we got this API to detect. So it's running on Kubernetes and we get this result.
Exactly. Right. And now you can, once you deploy this, the whole thing will be running inside Kubernetes. Right. So for example, if you give the deploy command now with this command, this command, it will have it running in the cloud. So what have you achieved? You have an inference engine, AI inference engine, running in the cloud in a Kubernetes cluster, right? And that inference engine is fairly high performance, robust.
So Asif, for the models that need to be trained on a sort of a recurrent basis, then do you just automate the process by saving a save point and pushing it through? Is
Yes,
that
so what we do with my team is we literally have a model repository and versioning and so on and so forth. So every time a model gets, so some of it you get through the weights and biases and so forth. You do experiments and you keep track of which is better. But at the end of it, if you want to push a model to production, you follow the same pipeline. You version it. It's your next version. A build process will add the next version number to your model, right? And it will add metadata, et cetera, to the manifest file that goes along with the model. Then we have it. Then we'll have it in a specific model registry, right? Which is our internal thing. You just keep it there, and then what we do is when we push it to Kubernetes, and that is the next example I'll give you. See, here I just took from the model zoo, you took RESTnet, which is pre-built, just download a pre-trained model. But if you have trained your own model, how do you load it? It's just 2 more lines. But so what you do is you'll go to the model registry, the latest model, you bundle it up and push it to your Kubernetes as part of deployment. So you deploy 2 things. You deploy your code and you deploy the model.
Yeah, that's correct. Now, even in case of pre-trained, right? If you have a layer on top of it, then you would have to still deploy your own model, right?
Yes, yes. So if you do fine tuning,
Correct.
like fine tuning, you still ultimately you'll save it in a file that becomes your model. So
Right.
when you go, the only difference between this and a Hello World normal Java application, right, or I don't know, something like a travel application in Java or pet store in Java, the only difference is that in a pet store, the database is separate, and you just ship the code to a machine and it goes live. Here, the difference is you package the code and the model to pick it up. And some people don't even do that. What they do is they store the model in a database. And then just like a normal pet store application will go to the database for data, in their case, they will go to the database to fetch the model as a binary blob.
So in this case, are you really by database? Are you referring to what database here?
Anything, Oracle, MySQL, Postgres, pick your choose
Because
one.
you're saying that because your model is just some numbers, right? Matrix. That's why
No,
you're
it's just a file which contains
fine.
weights and biases. That's all.
Okay. No, that's very interesting, Asif, because if you have a model that you want to apply on a data in a database, then you really don't need to pull the data out in mid-tier, right?
So that's right.
You
So
can
it
put
will be a single SQL query, right?
correct. You can essentially execute it in database itself because your model resides in database.
No. You don't want to execute it in the database. So you're getting into Oracle. Okay, that's a separate discussion. I was engaged with that team, the advanced analytics team in Oracle database. No. Here, you just retrieve it back to your Java application and run it. But
That's what.
yes, the possibility is there. See, Oracle Stack was that if the models are built and trained, you can store it. It becomes sort of like a stored procedure. You can execute it in the process space of the database itself, right? That
Yeah.
is how the Oracle data mining group works.
Yeah.
It's a valid strategy, but it is not commonly practiced. The reason it's not commonly practiced is database servers are not put on machines which have GPU, right? Those and now almost all inferences we like to do it on machines that have GPU.
Maybe we can have a separate discussion, Asif. I have a few more questions on that, but may not be in the interest of a broader audience here.
Yeah. By the way, there's a typo. I noticed there's a sentence. There are. It shouldn't be there. So this is it. So guys, this is it. I'll take a break and let's convert this session into one-on-one helper after the break. Let's get you guys through your problems.
Okay.
So,
How long is the break?
Break, let's make it, it's 8:30. Let's make it for 20 minutes.
Okay.
Right. So let's do that. And one more thing, guys, I've taken you on a long journey, right? Typically, people always use a simpler route. They'll just take your Python to production or your Node.js or something. Data science communities are very tempted to just put their model into Flask or into Fast API. My team, one of my teams does that. Get away with it so long as your traffic is low. When the trouble happens, when you scale out and you start paying a large bill on the cloud. So what I've showed you is a path that is more sort of, how should I say, harder, but more sensible in the long run.
Do you have any further tips on this container image not being allowed to be added there on that? Because
Yeah, one-on-one, let's fix everybody's environment. See, some of you may have missed a step. In some of you, we need to give some permission. So let's do one by one help.
Okay, all right.
All right, guys, I'll stop the recording because after this we'll do one-on-one help. And